Okay, so here's example 3. You are planning an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables will seat 6 people, and large tables seat 10 people. The equation 6x plus 10y equals 180 will model this situation, where x is the number of small tables and y is the number of large tables. Question says to graph this equation and then interpret the intercepts. So in order to graph the equation, we have to take this example, 6x plus 10y equals 180. And I'm going to use the covering up method, and we're going to solve for the x-intercept first. So if I cover up, let me do it this way. If I cover up the y, you'll see 6x equals 180. So I'm going to write that equation. Now I'm going to solve this equation for x, and I end up with x equals 30. This number represents the x-intercept. In other words, this is the point 30, 0. Now I'm going to do the same thing with the same equation, but this time I'm going to cover up my x. When I do that, I see 10y equals 180. Again, I'm going to solve this equation for y, multiply by the reciprocal, and we get y equals 18. This number represents my y-intercept, or the point 0, 18. So the 2 points I need to graph are 30, 0, and 0, 18. Before I go further, why don't we discuss what this means? This means that there are a total of 30 small tables and 0 large tables. This means there are 18 large tables and 0 small tables, because x represents the small tables and y represents the large tables. Okay, so now we're going to take those 2 intercepts and we're going to graph them. I'll go my graph. And again, you might want to just quick sketch this yourself. It might be easier for you. It's a quick sketch on your own. Okay, so here's my graph, and I actually counted by 2s each line, but it's a very small graph, so I kind of skipped. Okay, so we're only looking in the positives here, and my 2 points are 30, 0. So I'm going to go over here to 30 and move 0. That's my x-intercept is there. And my y-intercept is 0, 18. I'm going to draw that there. Now, this is much better done if you can arrange it to do it on a graphing calculator to make sure you get it precisely, because we're going to be answering the question after we graph it. But we're going to do the best we can today. That's the idea. That's as good as we're going to get here. So anyway, just give me a second. I'm just looking to make sure I have this lined perfectly. And I got it. Okay, that's about as good as I'm going to get here. All right, so the idea here is we're going to go to the second part of the first question. And that one says, find 4 possible solutions within this context of the problem. This is part B. All right, find 4 possible solutions in the context of the problem. So let's take a look at our graph. So if we just take a look at this graph, I'm just going to zoom in a little. There's only 4 possible solutions you can get from this graph. The possible solutions are 0, 18, and 30, 0. Those are 2 solutions. And there are only 2 others from this graph that we can get. One of them is at 10, 12. And the other possible solution is at 20, 6. It's right here. So my graph's a little off. But if again, if you have a good online graphing tool, similar to Desmos, then you would be able to see it much, much clearer. So these are the only possible solutions. So this is 10, 12. This one is 26. This is 30, 0. And this one is 0, 18. These are the only possible solutions to this problem, which means the only possible ways we can fit 180 people at those types of tables is either we could have 18 large tables, we could have 10 small and 12 large, we could have 20 small and 6 large, or we could have 30 small. So that's the only possible solutions to this problem. Okay, so that is the end of 3.4. Please complete the monitoring progress problems.